All right, so I think I'm recording. Let's take a look at this problem. We've got two functions f and g, and they're asking us in parts a, b, and c to build new functions. In part a by taking the product of f and g, and in parts b and c by taking the quotient of f and g. And then once that is done, in part d, they're asking us to identify the domain of each one of these. So we'll find the domain as we go along and stuff. So here in part A, as I've mentioned several times, the naming of this is pretty clever. They could have called this new function h, but then that doesn't tell us how to build the function to where if the title of this function is fg, then it's understood that this new function is obtained by taking function f and multiplying it by function g. So let's see, what do we get there if we do that? For f, we have the square root of x squared minus 16, and I'm going to write that over 1. And you can always do that. You can always take something, divide it by 1 to create a fraction. And here, for g, I have x over x minus 16. Now, there's this x squared minus 16 factors to x plus 4 times x minus 4. There is no way that I can simplify this radical. This numerator, this factor in the numerator and this factor in the denominator are not the same. They do not divide to 1. I can't come in and cancel anything with that. So all I can do is just simply multiply straight across in the numerator and the denominator. In the denominator, I get x minus 16. And I suggest that you write this x in front of the square root so that if your handwriting is sloppy, if you write it afterwards, if you wrote it over here, then someone could not understand if that's underneath the radical or not and exactly, what that means. So you'll often see textbooks and teachers advise students that you use the commutative property and that you write this x out in front. That's a common thing to do. So there's our final answer for part A. Now, in part D, we want to find the domain of this. But you must be careful when you're finding the domain of some function that you built if you just come along and use the final result. In this case, there was no simplifying that occurred, so I think we would be okay. But to be doubly sure that I'm doing this correct, what I always do in finding the domain of this product is find the domain of f, find the domain of g, and intersect those two domains. So this is how I always, and this is what I suggest that you do, that in finding the domain of something that you have built, and if it's f times g, or if it's f plus g, or f minus g, or using the commutative property, any ways that you can rewrite that, is to intersect these two domains. So we need to find these two domains, and that's going to be a little bit of a challenge in finding the domain of f because we have a quadratic inequality to solve. Now, we saw in a previous skill that we did solve quadratic inequalities. So to find the domain of f, we need that x squared minus 16 has to be greater than or equal to 0 because we're underneath the square root. Now, we don't have to worry about division by 0. There's no variable in the denominator. And to solve this inequality, we factor this x plus 4 into x plus 4 and x minus 4. And if you want to refer to those as critical points, that's what they are often referred to as. Our first decision that we have to make is to whether to leave these out of the domain or to include them in the domain. And since it says greater than or equal to, because that arrow is underlined there, we include these in the domain. So now, with these quadratic inequalities, we have to make a decision of either to shade the numbers in between there or to shade the numbers that are away from the center out in the tails. And I always use a parabola. I know that the graph of this x squared minus 16 is a parabola that opens upward. And I know that what I just found with the -4 and +4 are the x-intercepts. This x squared minus 16 are the y-coordinates on this parabola. I only want y-coordinates that are greater than or equal to 0. Those y-coordinates live above the x-axis. If you're below the x-axis, the y-coordinates are negative. Negative is down, positive is up. So I want the corresponding x values for all these points that are above, which means that I want these values, because I guarantee that every point up here, that for an x less than -4, you're going to be above the x-axis. So the domain for this function f is all real numbers up to -4, including -4, but excluding all of the real numbers between -4 and +4, and then to include 4 to infinity. All right. Now that's just the domain of f. Let's keep my picture. I don't necessarily need the parabola in there confusing things, so let's see if I can erase that part of it. That was just to help me determine where to shade in here. All right. And let's rearrange this a little bit better. There we go. I think that's a little bit more clear. So all of this work was just for this first part, the domain of f. Now I need to come in and find the domain of g. Well, let's look at g. G is easier and much simpler to find the domain because we don't have a radical to worry about. We do have a variable in the denominator, and all we have, we don't even have to factor this. All we have to do is recognize that we want to avoid x equals 16 because 16 minus 16 gives us a 0 in the denominator. So if we recognize then that the domain for g is all real numbers excluding 16. Oh, and I wrote that right underneath there, and I did not want to do that. You know what? Maybe what I should do is move this off to the side like that. Yeah. Sorry about this. Already, sometimes I am conscious about how long it takes for me to explain things. And if you're watching me just rearrange things, I don't know how beneficial that is. Sorry about that. Now, I know on this number line that 16 is way over here. 16 is to the right of 4. So I know that 16 lives over here. Now, in the domain of G, I'm excluding 16, but the entire number line is shaded except for that 16. It's all real numbers excluding 16. So if I want to find the domain of this f, of this product, of this new function, fg, then I have to intersect these two sets. So to be in the intersection, you have to be in both sets. -4 is in both sets. -4 is in my intersection. +4 is in both sets. +4 is in my intersection. 16 is not in both sets. 16 is not in my intersection. So to the left of -4 is in both of these sets. Because remember, you have to be in the top set, and you have to be in the domain of F and be in the domain of G to be in the domain of the intersection. Between -4 and +4 is not in this set, therefore it's not in the intersection. Between 4 and 16 is in both sets, therefore it's in my intersection. And greater than 16 is in both sets, therefore it's in my intersection. So now I have a picture of what my solution set looks like, and I know how to write it now. That the domain, the answer they want for part D for number A here is that we're from -infinity up to -4, including -4, and then there's a break. And then from +4 out to 16, and there's another small break, and 16 to infinity. So that's the domain of this product. So we have now finished A, and for part D, we found the domain of that. So now we're ready to move on to part B. I'm not going to erase everything because I'm going to keep some of this information. I don't need this work. And although my answer in part B might end up being the same as for the domain of part A, may end up being the same as the domain for part B, it's not necessarily going to be the same, so I'm going to erase that. And this was the intersection of those two, and like I say, that may not be our final answer there. But for part B, it is true that what the domain of F, the domain of G are not going to change as we go from part A to part B to part C. All right. So let's come over here and figure out what this new function is, f over g. So as I keep mentioning, it's a nice way to title this because it tells us how to build this new function. To build this through division. So f of x is the numerator, and that's x squared minus 16, and g of x is the denominator. But since this is a complex fraction, I have found that students do better if they write this division instead of using a fraction bar, if they write it using a division symbol like this. And I'm going to make this over 1. So that just jogs people's memories maybe a little bit better in recognizing that division is the same thing as multiplying by the reciprocal. That we can take this first factor and now multiply it times this second factor if we take its reciprocal, if we flip this. So we need to be careful. The parentheses are important here when we multiply these together. And I suggest that you write this binomial 1 in parentheses and move it to the front of this radical so that no one thinks that that's underneath that radical. And then here in the denominator, it's just x. And nothing, you can't cancel terms, so nothing simplifies there. And now we want to find this domain. But like I say, when it doesn't simplify, I think you'll be absolutely fine in finding the domain just given this expression. But when it does simplify, that's when you lose information, and you should always, I believe, go back to the definition of how to find these domains. And the domain of f over g intersects f and g, the domains of f and g, but we also have to intersect the set, and I'm a little bit lazy in my set builder notation because I normally, honestly, I just write g of x not equal to 0. But that's a little bit of a hybrid. That's not the set builder notation. I guess if we can, it's not worth it to formally go through it. All right, so I've got the domain of f and the domain of g sketched over here. This g of x, I temporarily let g of x equal 0 and see what values of x make this true, and then throw it out, then avoid that. Well, g of x is a fraction, and we know that a fraction reduces to 0 if the numerator is 0. So this numerator is a simple expression. It's just x. So if x is equal to 0. So what this tells us, that g evaluated at 0 is equal to 0, and we need to avoid that. So the set of all x that avoids having this denominator be 0 is all numbers excluding 0. And 0 is between -4 and +4. So I would suggest that you kind of line that up a little bit if you're going to use these number lines to help with a comparison. So now, to find this this domain of f over g, let's actually find the picture first, and then from the picture, write it out. So -4 is shaded in all three sets here, so -4 is going to be in my intersection. 0 is not shaded in all three sets, so 0 is not going to be shaded in my intersection. 4 is shaded in all three. 16 is not shaded in all three. So now I have to look, is to the left of -4 shaded in all three? Are they in this set, and in this set, and in this set? That's what the intersection mean, is that word and they are. If you're to the left of -4, it's shaded in all three sets. Now, if you're between -4 and 0, here, let's put a 0 in here. And we see that you're not shaded between -4 and 0, so I'm not going to shade it in my intersection. And from 0 to 4 is not shaded here, so it can't be shaded in the intersection because it has to be in all three. If you're between 4 and 16, well, it's shaded here, it's shaded here, and it's shaded here. So between 4 and 16, it's shaded in my solution set. What about to the right of 16? It's in all three sets. It's in this set, and this set, and this set. Therefore, it's in my intersection. So now I have a picture of what this domain of f over g looks like. And it's from -infinity. What? I'm going to need more room to write that. So let's erase all of this. And let's come down here. And to intersect these three sets, over here is our picture, and this is what we get. From -infinity to -4, including that endpoint of -4, and then there's a break. Now, this was not shaded, and neither was the value surrounding it, so that's just a gap all the way till I get to 4. And then to 16, and then from 16 to infinity. So there's my domain for this part B. We found the function itself, and then we used the domain of f, the domain of g, and we considered that we avoided this denominator g of x to ever allow it to equal 0. All right, so I'm going to erase this part. And I'm going to erase this answer down here because it may be the same, but it may not be. Now, I'm not going to erase my answer for part B because what I notice is that in part C, it's the reciprocal. So if I want to find the expression of this new function, I just need to take g of x divided by f of x, which is the reciprocal of over here. So the reciprocal of this result is x over x minus 16 times the square root of x squared minus 16. And unfortunately, we have a radical in the denominator. So we need to rationalize that denominator. So we multiply this by the number 1, but we're clever in how we write the number 1. We write it as x squared minus 16 over x squared minus 16. So what that means is that our final answer in part B, the formula for this new function, is x times x squared, the square root of x squared minus 16, all over x minus 16 times x squared minus 16. And I'm going to leave that in factored form. I'm not going to multiply that out because I argue that most of the time when we're working with fractions, it is more convenient to have our fraction in factored form than in some kind of standard form. All right. So now I no longer need this answer for part B over here. So I'm going to erase it just to have space. And I'm going to move our answer that we just found for part C and move it over here out of the way. We want to find the domain now of this new function. This new function, g over f of x, we need to find the domain of this. But we can't come in and use this formula as it's written because we know that we rationalize that denominator. We're not going to get the right denominator unless we go back and think about what the definition of finding this domain is, and that's taking the domain of f and intersecting it with the domain of g and intersecting it with, well, this time we have to avoid f from ever being 0 because it's in a denominator. So we need to figure out what this set is. We have found the domain of f and the domain of g, and we've kept that through our work over here. And now we have to consider, is there a solution to f of x equaling 0? We're going to temporarily let it equal 0. And we look at this and we say, yeah, there is. If we have the square root of x squared minus 16 equaling 0, we square both sides. And if we factor, we see that we want to avoid -4 and +4. It should be easy to see in factored form that -4 and +4 are solutions to this. So what this is telling us is that f evaluated at -4 is equal to 0. Well, we can't have that. F can't be 0. It's in a denominator. And this f evaluated at 4 is equal to 0. Well, we can't have that, again, because f is in the denominator. So this extra set here, all x's that satisfy this inequality right here, that all of the x that make this not equal to 0, well, we exclude -4 and positive 4, but everything else is okay. So let's include 0 and 16 on our number line because we know those are points of interest. So to figure out the intersection of these three sets, let's first look at these points of interest. Is -4 shaded in all three? No. So -4 is not in the intersection. Now, oh wait, I put 0. See, 0 is not an endpoint for all three of those. Yes, it's true that 0 is between -4 and +4, but it's just gonna 0 is just one of infinitely many numbers between -4 and +4. I'm going to jump over here to 4. 4 is shaded in the first two, but is not shaded in this one. Therefore, it's not shaded in my intersection. You have to be in this set and in this set and in this set to be in the intersection. And we see that 16 is not in this set, so therefore it's not in the intersection. Well, what about all these values to the left of -4? To the left of -4, they're in all three sets, so they are in our intersection. Between -4 and +4 is not in this top set, therefore it will not be in our intersection. What about between 4 and 16? Between 4 and 16, the numbers are all shaded in these three sets, so they're shaded in my intersection because it's here and here and here. And to the right of 16, the same thing. It's in all three sets, this set and this set and this set, therefore it's in my intersection. So here's a picture of our final answer, and let's see if we can write that in interval notation. So I claim that for this part C, our domain of G over F is from -infinity to -4, excluding -4, from +4 to 16, excluding 16, and then from 16 to infinity. All right, so hey, I hope that helps, and ask any questions as needed, and I'll talk to you later. Bye.